Welcome to qnawire.
So we start by assuming the plant grows in the direction of the local normal force, let's call it Fn, and in the rotating frame of the platform there is an outward fictitious force of magnitude Fc, which is equal to mv square over r, or we can also write it to be mr omega square. Now let's draw the free body diagram for the rotating frame of reference. So we have a gravitational force downward, the centripetal force, which is mr omega square, and there is the local normal force at an angle theta from the vertical, and the plant grows in the direction of Fn. Now, since the object is not accelerated in that frame of reference, the normal force must be a vector sum of the other two forces. So let's write Newton's second law in this frame of reference. So we have F net, or sorry, so we have F net, which is a vector sum of all forces to be equal to mass times acceleration. Now let's write this problem for horizontal and vertical components. So we have sum of all vertical forces to be equal to mass times acceleration in the vertical direction, and sum of all horizontal forces is mass times acceleration in the horizontal direction. Now since the object is not accelerating in this frame of reference, we have Ay and Ax both zeros, which makes the sum of both forces to be zero. Now in for F vertical, we have two components in opposite directions. So we have mg downward, and Fn has a component upward. So if we take positive y to be upward and positive x to be towards right, then we get Fn minus mg to be equal to 0. Sorry, forgot to write the component. So we have Fn times cosine theta, which is the vertical component, minus mg equal to 0. Similarly, for the horizontal component, we have mr omega square, which is in the positive x direction, minus Fn sine theta equals to 0. Now we can solve these two equations to find an expression for the magnitude of Fn. So solving this equation, we get Fn to be equal to mg over cosine theta. And solving this expression right here, this equation, we get Fn equal to mr omega square over sine theta. Now since both of them represent the same value of normal force, the right hand sides should be equal. This means that mg over cosine theta is equal to mr omega square over sine theta. And we simplify this, so we get tan theta equal to r omega square over g. And this gives theta to be equal to tan inverse of r omega square over g. Now as you can see, theta is positive since this value is positive. So in the inertial frame of reference, the normal force still must point inward. as you can see. Now, the horizontal component of this normal force is providing the centripetal acceleration which points inward. Therefore, our assumption that the plant grows in the direction of the local normal force is satisfied, and since this local normal force points inward, the plant grows inward more than outward.